Hey guys, this is Earth Science Week 16. Again, I'm Mr. Hayden. No one can see me wave on the internet, but I'm waving. A few things that we need to go over for this particular session. We've got 4 weeks left of school or so. No, I thought that was me for a second. I was like, whoa, I don't see where you were. But in general, there's about 4 weeks left of school. This is the issue with that. Some of your guys' grades need to be brought up. But you only have 4 weeks. So I'm looking around the room, again, I don't know specifics, but you need to make sure you bring it up. And people usually look away from me and squint towards the screen are the ones I'm talking about. And you look out and go, you're real serious. You need to bring your grades, guys. You guys really need to bring your stuff. No, but you guys have 4 weeks left of school. Your science notebook will be due starting May 11th, so that's next week. So if you're not going to come like after, like, say, next Thursday or something like that, and it's a different day, make sure I know when you're coming, because that would be nice. Just to make sure I have time set aside to grade for you. I have the pages in my room. You're going to do a self-analysis. Like, you're going to actually redo your own book itself, and you're going to give me what score you think you should get. Then afterwards, I'm going to give you the score that you get. Okay? And so we want to make sure that you're here between May 11th and May 22nd. If I do not have it completed by May 11th or May 22nd, guess what? What do you think you get on it? Sorry. It's a 2-week window. If you can't use the 2 weeks, you don't deserve it. So make sure you get it to me. If you want to bring it next week, that's fine. Speaking of that, there's a lot of random tests here, this, that, might have to go to, there's a lot of stuff going on at the end of the year. So for some reason, if I need to cancel the class, then you keep checking your emails. If I give you an assignment, like I say, this is canceled, but click on the attached document and do the work from there, great, that's your assignment that day. If I don't give you one, you're welcome. You're off there. Sometimes you go into the classroom and stuff, they put a movie on. That's bad. Okay. So just make sure you pay attention to your K-notes. Look at them daily because they can change. A lot of teachers are getting pulled in different directions at the end of the year, and I want to make sure that you guys don't just show. I want you to show up. They don't have to do the straight. Oh, I'm saying out here. I'm going to cry out the rest of the day. I don't want that because tears are. Breathe. Yeah, I tried to. Okay, make sure all your assignments, quizzes, tests, and potential questions are done before the end of the semester. Again, 4 weeks, guys. 10 4 weeks. We want to make sure that all gets done. What else do we need to go over? Am I missing anything? Do you guys have any questions about the class or anything like that? No? True? False? Yes? No? Good. Well, any questions? Making sure, because I'm going to keep going. All right. So the essential question for, I forgot it's not like that. It's like this. The essential question for today's kind of lesson is, is this all right? Yeah. Please. I'm very polite. Please. Well, at least I wrote everything correctly. Last class, I noticed I didn't have to describe in there, really items in there. And then I had in your own world, so didn't say words, so it was pretty bad. But it was fixed. So please describe in your own words, briefly. You want to describe the development of the solar system from the Big Bang all the way to today. It literally can take literally thousands of things, okay? It's really good. I just want them very generic. What do they think this is what they think theory is? Explodes, this is how solar systems start, spinning around rotation, boom. Hydrogen helium going to the center, explosion of fusion, and then planets start to develop, yada, 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 yada. Okay? Probably take about 3-4 sentences, nothing crazy. That's the essential question, make sure you know that. And then again, we're going to start going into the test. Every single one of these slides is specific to a question. I did give you a question straight at the beginning. I actually wrote the question on there for you. You just have to look it up and get 3 points up in the right answer. You're welcome. Okay, so look around the room. Are we good? Oh, so someone told me to write the scribe. Okay, she technically did it, but I did. Alright, just describe it twice. That's how important description is. I put twice. Alright, so, unit 4 test prep. Okay, so you want to know how our solar system has developed through observations today. There's a very specific slide in the case that actually says, based on observations today, you should probably know that one. Okay? And you like my voice? It goes into like super like cool voice. That's my cool voice. No, this is my position. Ladies and gentlemen, boys and girls, we're going to take a journey into the development of the solar system. It's like a billions of years. They're still developing today. That's my no, I should start speaking for others. That's it. Wait. So make sure you guys know again how it developed from today. Kind of leads to the next question. Yeah, it came up. By the way, these aren't the exact questions. I couldn't just give you the question, that's cheating. But what I did is I looked at the question itself and said, what does the person need to know to get this right? So there you go. You didn't know that. Okay. When the solar system formed, what was left over in the solar system? Yeah, what was left over? So the solar system forms, slams together, creates the sun, ignition, blah, blah, blah. There's an explosion that pushed a whole bunch of the dust and everything out of the way. Right around certain rings around certain areas of rings around the sun, all those rocks started slamming into each other along those rings. Guess what? Boom, planet, good for us. We happen to be here because of it, good for them. And then there's other things that are left over. Make sure you have those. Know the following scientists and their contribution. So, Doppler, Copernicus, Halley, Kepler, know who they are and what they did and why it was important. Here's a hint. If you know all four of those, you will get the test question right. Because one of the questions asked specifically, you need to make sure if you know all four, you will make sure you'll know that other one. You're fine. You literally just go back to the room and like start talking about it. I don't get mad like other people. Not you. Alright, so yeah, make sure you know those four guys, alright? Guys probably had beards, probably more awesome than mine, probably. They had a longer time and they didn't have any girlfriends or wife, so you probably didn't have anyone to worry about. So I can't make mine do wife. Make sure you know the following terms. Again, know what a moon is. Know those various terms right here. Now, the one thing about the moon I was going to say, and it doesn't really have anything to do with the task in general. Sometimes they'll call moon satellite. Because satellite, even what's a satellite to you? What do you think it is? Yeah, we put it into space. It gives us like communication. Essentially, believe it or not, the fact that we're just putting something into the rotation around our Earth is like a satellite. We didn't. We're not that egotistical. But still, the definition is just an object that rotates around a larger object. So the moon is a satellite to the Earth. The Earth is a satellite to the sun. The sun is awesome. Yeah. You can. And it's funny, you're like, oh, look at that satellite up there. You're like, where else see it? Oh, it's huge. See it's right there. You're like, no, I don't see it. It's like, oh my goodness, it's there like 25 days of the year. You're like, oh. And so they're like, you know, what are we talking about? People don't realize that the actual definition for the moon. The satellite, even though it's not a rock, and we call it the moon just for fun. But just make sure you know the definitions of each one of those. You're going to planet in the year and all those. All right. Okay, make sure you know all the names of the planets there. I'm kidding. Did you guys read it? Can you read it? The third one over is Waterworld. It's Waterworld. This is the real planets, right? Just a picture. Some people out there like, yeah, that's our solar system that you don't know about. Those are the invisible planets. So just in general, make sure you know, okay, gas planets have very specific criteria and they look very specific. You know what a gas planet is. You just look at it and like, the gas planet's huge. The terrestrial are the ones that are like Mars, Earth, Venus, Mercury. Those are the rocky planets that come closer, or that are closer to the sun. Story. Look. Look at it later. That's hilarious. Just know what they have in common. Even though they're so different, smaller, rocky, blah, 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 bigger, yeah. They have things in common. Make sure you know what those commonalities are. Now, this is the give me question. This is the question on the desk. This is it. This is it. Very, like, written, very specific. Which feature indicated a period of heavy bombardment followed by a period of low bombardment in our solar system? Now, let's just look at the question. What is bombardment? Bombardment. Very good. It hits something, but like, for example, say you're sitting there and I start just throwing tennis balls at you. I'm bombarding you. But would that be that's a low bombardment? Just me. So now, everyone in the room, hundreds of tennis balls, said, no, Daniel, please. Then it'd be more of it'd be a heavy bombardment. Okay, that's the difference. Back in the day, guys, we didn't have this cool earth, like this cool air and nitrogen and the O3 and all these ozone layers. We didn't have any of this stuff. So this Earth was just boom, 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 getting hit. The moon gets hit all the time still. And there's kinds of heavy bombardment and low bombardment. What is the difference, okay? So just look at that. What?
You said what feature? You said nothing.
Yeah, but look at the features. This is a very specific answer that you'll be able to find right away. Just so you know, this is a gimme. If you want to just write it down, so it's going to be dropped. Oh, you did? I think I already took this thing. All right. Again, know the various energy levels. So the rays that come from the sun isn't just light. And it's not just the fact that light bounces off like this beautiful beard, and you can see it. That's not all that comes out of the sun. There's gamma rays, X-rays, visible light, microwaves, all these things. When you step outside, you're getting hit by it. Yeah, there you go. Microwave is a thing, but we use it to heat up stuff, like basically agitated water molecules for cooking, but it's actually kind of like creating radio waves inside of it. Not radio waves. Microwaves, thank you. Microwaves inside of it, but there is microwaves out there too. Basically, gamma rays, when you look it up, you'll see like this. Like this. It's really cute. And like other waves, such as even like light waves, depending on which light wave, it's more like this. Or here. Kind of hang up. Now you'll know which one's a high frequency or a high level, which one's a low level by looking those up, okay? Good talk. 1 second here. They spelled microwaves wrong? What? Microwaves! Hey, watch out for those microwaves, all right? Okay, I'm still microwave. You do realize as I'm doing tests, and people come in, hey, Mr. Hayden, I have a question. All right. Know how a telescope works. Thank you for pointing that out, by the way. Makes me feel good about myself. Yeah. All right, yeah. So know how a telescope works. Again, telescope, big, long tube, typically taking light, reflect off a mirror. You look at it, make it think far away, look close. Yay, the thrust. You use a mirror. Just understand how it works itself. This is a reflecting telescope. There's other telescopes. Just make sure you know it's going. Okay, so you want to make sure you know the depth of a star at various masses. So all suns, we consider a sun, stars in general, are going to go away. All of them. Okay? If they're big, fix the pouch. If they're big, they have different light or different depths than the small ones. And you didn't know what those depths are. It leads to the next question. That's actually the next one after this is asking, what is the life of a sun or whatever, that star? You got to know that. What happens from the very beginning? Rotation, comes together, blah, blah, blah. How big is it? How long does it last? What happens after it goes out? Does it just explode? Does it create a black hole? Does it create a white dwarf? What does it do? Based on its size, it creates a very specific one. I want to go and say theoretically, too. No, these things take billions of years. We've only been around for 10,000. We've only been intelligent enough to see it for the last 1,000, maybe. So, I mean, we really only see like what we barely have a glimpse of what's happening. We don't really see what's happening over time. We make those assumptions based on what we see, what it's made of, and but we never actually looked at it like, look at the star exploding. Yeah. And it exploded, and we're going to go away another couple thousand years and see what happens. All right, so know the life cycle of a star. This is actually a very good little picture. I recommend finding one of your own on the internet and using it because it's going to tell you if it's high mass, low mass. Our sun's like right here. It's not quite low, not quite high. It's right there. Eventually, it will expand, engulf pretty much all the planets, burn everything, and then come up, slam and collapse on itself. Not create a black hole, but it'll create a white dwarf. And then it'll then create a black dwarf. Okay. If it's too big, we'll create a black. We'll create a black hole. Yay! Hey, good fraction. It'll be around for it. Yay! Never know. Never know. Might be around for the next 4 billion years. Never know. 4 days. Oh yeah, you never know. All right. Did I spell something else wrong? No. Okay, good. You misspelled ha 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 ha. No, you misspelled ha ha.
Correctly.
Capitalize with that. Exclamation.
Your science, not grammar.
Yeah, grammar. All right. Make sure you know how to classify the following or how to even look and figure it out. So just know the definition of a regular spiral solar system, barred solar system, elliptical solar system, and then your irregular one.
You already took this test.
Well, there's some solar systems that believe are two stars are actually rotating around each other. It creates a weird little dynamic. You have two stars rotating around each other. They're still rotating all these times. I don't know what to do. Who do I hang out with? They're all my friends. And then they're all in the place. But again, theoretically, all we can do is look out there and say, oh, look, there's the star. Made a small occasionally lower glimpse during this exact period, and this many times ago. Therefore, there must be a routine. Until we go there and see it, probably not a problem. Which we had a conversation last class. Think of how big space is. It leads to the next question, I believe. Is the next one the one about the... Oh, no. The next. We'll get that in a second. Remind me. You're in charge of reminding me of that. Like expansion of universe. All right, so make sure you know what the periodic Doppler shift is. Know the definition. Know what it is. It's a weird question, so just make sure you know everything about that word. Yeah, Doppler 7000, the one that's on ABC. Well, yeah, HD. QR is CLYN all the cool stuff. It's funny because when I grew up, they didn't have that. They're like, oh, the satellite, it shows that there's rain coming. And I was like, let's check the Doppler. Doppler 2000. And I was like, check the Doppler 7000 HD plus 2Y699 or 42. It's all HD, so you the exact street that's dropping on them.
They're like, we can go to that street instead of the rain.
That's pretty sick. Well, it's going to be hot. It's going to be hot. It's going to be 930 degrees. It's hot. Yeah, literally. Literally and figuratively. All right, so let's go next one. Okay, here we go. So how do we know there's an expanding universe?
Big Bang.
Big Bang, good for us. But how do we know that it is the Big Bang Theory? Why has that theory even come up? There's something called redshift. Redshift theory. There's a certain lens, whatever, it's the light, the way it looks, if somebody's coming toward you or going away from you, is a different color. When it comes towards you, it's a blue light that basically shows up. Then it goes away from you, it's red. And when they put these lenses, when they put this light lens over the universe, they just look out there, everything's red. Which means everything is moving away from everything. They think you're shotgun blasting when they've never heard or seen and know the concept. Then you shoot it, and the buckshot shoots out and it expands and goes outward. They do not go closer to each other. They expand from a certain point that moves away. So this is the weird thing. If it's expanding, what is it expanding into?
More space.
Well, the more space exists because but is it expanding? But what is it expanding into?
What was it from? And then it's a black hole.
That's a real theory. I don't know the name of it. There's a real theory that Daniel was making kind of a joke, like, oh, at this point it's out, blah, blah. But he's really like, it's like a real theory. But that the expansion believes that it will expand, they will go out to a certain point, kind of go, oh, I'm done exhaling, and I'm going to go in and inhale again, and it'll start to re-pull them back into each other, back to the Big Bang, and happen again, and happen again. And theoretically, what if that's already happened?
Oh no.
And we wouldn't know how old the solar system is because it's remade. It could have happened billions of times, but we just happen to be the ones left. In the one organism on the one planet in the one solar system.
There's another solar system, it's like on the outside of the
It's kind of weird.
Are you going with we're the one organism?
We're the organism.
We are the one organism?
We're the only one that matters on this planet. We're the organism. It's because we think of human life. Let me give you an example. If we went to a whole other Mars or something, what would be more interesting? You showed up there and like a three-legged dog with like horns, or like a person came and goes, hey, how are you doing today? Oh, it's like that. The dog would be more interesting. The dog, the person, right? No, obviously, that's what we care about. When we find, like, when we say we're going to go find aliens, okay, there's bacteria and all that other stuff out there. It's kind of like a thing. It's just, is there an intelligent life? Is there the ability to go and say, hi, how are you doing? And it could be better. Independence Day. We need Will Smith. No, we need him. He has a son, right? He's young enough. He'll be the commander. Have you seen Independence Day? He can fly their ship.
Really?
Yeah. Yeah, we should do that. We should do the movie. That is amazing. It's a documentary. It's a documentary. Better? What? I don't understand. Oh, hi, you got it is better grammar. I mean, mark you down for that. So make sure you again know redshift theory, know the idea of moving apart from each other, a single point moving outwards. But it's crazy when you sit there and think about it. Make actually us do that. Two more questions real quick, so we can stop the recording. Is know when the sun will not set or it will not rise above the horizon or below the horizon if you're talking about it being already up there. What would be the season and the latitude? So what it's saying is, remember when we did that simulation and the sun was just kind of spinning up to the top?
Yeah, that was like kind of,
what latitude was that, and what season was that? Got to go back and look at that up. And then also, what if it never showed up? What season? What latitude? You can be the same latitude, but what season? The opposite.
winter.
Well, whatever it is.
Winter at -1
It
degree.
depends on what latitude, where you're at. If you're down at the bottom,
91 degrees. Top 91 degrees in winter.
north or south, in your face.
North.
Bam, in your face.
In north.
North, and you're right. So it doesn't matter. You have to say specifically what it is. Okay, you also know the various positions of Earth, the rotation around the sun, and just know how to tell if it's summer or winter where it's at. Here's a hint. If yeah. Okay, what's that?
No.
Family guy? No. Wait, what's with the movie guy? It's hot. That's all they do is go back to it.
Oh, no.
All right, so here's the tilt of the axis, which is on the right side of the picture. The axis is tilting towards the sun from the north, is tilting towards the sun, and it's tilting towards the summer. So you know they come in like the bottom is on that exact position. Point at summer, not point at winter. If it's in between, fall, spring. All right. So, just so you know, that's it. If you have any questions, make sure you ask them. Make sure you do the essential question in the Dropbox in the class. Make sure you get credit if you're on the internet. I'm going to go ahead and close the recording off. You can take off if you want on the internet. Keep on class.